When we were working on our last set of assignments, we were looking at a thing called interpreting graphs. Now, in order to interpret graphs, we need to be able to graph them, right? So we need to have some way to see the information and then make it. Now, let's just talk about some concept here. Are you one of those guys that like routine? All right. Are you somebody that likes to do certain things in a certain way and are very, very, very careful to do it exactly the same way every single time? Well, if that's the case, then we can start thinking about working in factories, right? You might be that person that would be a good person to work in factories, because in Canada, we have large companies called factories, and those factories put together large and small items for use in our country as well as other countries. All products that we have must have a company's stamp of approval, i.e. telling you that it's an authentic piece, right? Which means that all items put together must be put together in a certain way. In the same way, what we're going to do is we're going to put together graphs in a certain way for the different types of graphs that we have worked with. You need to have that same sort of detail when you're making graphs. Now, let's do that first by understanding what a thing called a table is. Often, when we are looking at data, people tend to have some way of keeping that information organized. Okay, and that information that we use, often we call data. So anytime you hear the term information, we're really talking about data. Okay, now the best and quickest way to organize data is to put our information into a table. And tables are set up in such a way that they organize the data, right? They organize the data so that we can have two columns. We have an X column, and in this case, we have a Y column. Now, if I'm looking at the table below here, the X column will, well, hold the number of books. Okay, so if I think about it this way, this table represents X, representing the number of books, let's say, bought, right? And if I look at the Y section, this Y values represents not the number, but it represents the cost of those books. Okay, so imagine I was looking at this first column, this first row here. For 0 books, if I bought 0 books, it cost me $0. And when I buy 1 book, it costs me 20. When I buy 2, it costs me 40. When I buy 3, it costs me 60. When I buy 4 books, it's going to cost me $80. Right? So if you think about it, it is the cost of those books. But if you think about it, I would say it's the total cost of those books. All right. Now, here's my question for you. What do you notice about that table that we have there? All right? That's my question for you. What do you notice about the table? All right, so if I'm looking at that thing, it just tells us the following. So if I increase my number of books, if I increase the number of books bought, you notice this means the cost goes up. Now, I could even tell you for every step, every new book costs, if you think about it, 20 bucks. Right. So it's like, if I know that I'm going to get 2 books, I just got to add 20 bucks to the previous book total. Isn't that what's happening here? 0 books goes to 20, and then 20 goes to 40. Oh, so I just added 20 here, didn't I? I just added 20 here again, didn't I? Oh, look at that. I still just added 20 again. And it goes up. Now, whenever you use or you have data entered into a table, we're going to have to, when we enter data into a table, one of the columns is called the independent variable. Okay. Now the independent variable, you're always going to call that the y value. So that's the y column. Column, I think I spelled that wrong. The y column, MN. All right. Now, I spelled column wrong. Y column. Y column. Right? And we call that the independent variable. So the independent variable is the variable that we use, that we just pick, right? So this one we kind of pick, right? And then we also have this other thing called a develop, and the other one is called the dependent variable. This one here we're going to call the x variable, otherwise known as what you would find in the x column. So let's go back. If I was looking at this table here, the x column starts on let's try that again. We're gonna have to clip that, Jay. All right, so whenever you have data that's entered into a table, one of the columns is called an independent variable, right? And one is called dependent, right? Now, the independent variable, we're going to remember that this is our x values. And then the dependent variable is the y values. So depending on what x values we choose, the y values come up in a certain way. So if you think about it, when we are looking at our original set of numbers here, I choose the x value that I want. I choose the number of books that I want, and then I can look over to the right, and I can realize that if I choose 4 books, it's going to cost me 40 bucks. If I choose, 2 bucks, and if I choose 4 books, it's going to cost me 80. So 2 bucks gives 40, and then 4 books gives 80. Now, based on that, when we look at those tables, the y column depends on, so remember the y column, so we choose the x and then get the y. So we choose the x, and this represents what we call the independent part, and then we get the y based on the x, which is dependent. on the X, right? So whatever X values I have, I choose it, and then I know what my Y value is, okay? That's all it is. So in this case, we choose the number of books based on what we studied before, and this tells us the cost of those books. Okay? Now, it's a good rule to always place your independent variable on the left side of the table, and that the dependent variable is on the right side of the table. So let's go and take a look. So on our graph of book sales, you'll notice the cost of the books we said was on the left. Sorry, the number of books we said was on the left, which was our independent, right? And then the cost of the books on the right was our dependent. Okay? So just remember, your independent variable is always on the left. In this case, we're always talking about the X value of our chart. And then the dependent variable, Y, is going to be on the right. So it's always going to look something like this. Here's our X, and then here is our Y. Okay? All right, so here's an example of a problem that I want you to kind of consider. Sammy sells raffle tickets. One ticket sells for $3. Another ticket sells for, you guessed it, $6. So 2 sells for 6, and so on. Now, Sammy wants to figure out how much money she makes if she sells more tickets. We can construct a table to show how much money we're going to make. Now, let's do that. In order to do that, what we're going to do, I'm going to take this picture, move it over to the right. I'm going to take this table here, and we're going to look at it. So with our picture here, remember, we start with 1 and it costs $3. We start with 2, it costs 6. We start with 3 and it keeps going up. And you'll notice that this is our independent. And remember, our independent was, are you ready? That was the number of sales. And then this represents the cost. Okay, so remember, she's selling raffle tickets. So all we need to know is how many we sold and then how much money that we make each time. So these people, when they pay, it's going to cost, if they buy one ticket, it costs $3. Then we add $3. Then to go to the next one, we add another $3, and so on. And that helps us construct this table. Now, here's a question for you. If we were looking at the number of tickets, could you find out, sorry, if you knew the cost, do you think you could find the number of tickets? Let's look. So let's say it was $21. How many tickets would they have bought? So I would look at 21 and then, oh, look, it means that I'm actually using 7. So the cool part about these things is that these tables can help us predict the future. Costs. Okay, that is why we use these things. Okay, it's really easy for us to figure out the number of tickets and then find the cost by building on previous information before. So for example, if I wanted to find the number of 4 tickets and I only had 3, all I have to do is just add $3 in my table, and I just keep that table so I could use it later on if I wanted to understand where all these numbers came from. Now, let's construct a table for this problem here. Lolita performs a science experiment. She heats her water to a temperature of a temperature reading every 2 minutes. Okay, so let's go and do that. Let's make this table for 14 minutes. So we'll go X. We have 0 minutes, 1. No, it's every 2 minutes, right? Every 2 minutes, 0, and then 2 minutes, then 4, then 6, then 8, then 10, and then 12, and then 14. So here's what's happening. Let's read this whole problem one more time and kind of try to make sense of it all. Okay, so it says, with this problem, Lolita performs a science experiment. She heats her water and takes a temperature reading every 2 minutes. At 0 minutes, it's 24. At 2 minutes, let's call X, we'll change this to T for temperature. At 0 minutes, the temperature is 24 degrees C, so 24. And then the temperature rises 4 degrees every 24 minutes. So plus 4. 24 plus 4, 28. Then plus 4 again is 32, 36, 40, 44. And, oh, wait. 44 and 48 and 52. Okay, so we've got that. Now, based on that, you can answer these basic questions. We just finished the first part. So we just finished the first part. We figured out our table, and now, what's the temperature at 10 minutes? At 10 minutes, our temperature is 44 degrees Celsius. What's the independent variable of the table? The independent variable table is this one here. This was our X variable, and we said that this was the time. What trend do you notice in the table? Well, the trend is this. The trend is every 4 minutes, no, every 2 minutes. 2 minutes, the temperature goes up 4 degrees Celsius. And that's it, because that is what's happening. The trend is it's always increasing, but it always increases by exactly 4. And how much does it go up by every 2 minutes? 4. That's it. We're done. Okay, pause the video.